Okay, so in this video today, we are going to be focusing on the tangent function. More specifically, we're going to figure out how to actually graph this tangent function. Now, at this point in your classes, you have learned a ton of information about the cosine and the sine functions, right? You learned about the unit circle and you learned how to use the unit circle to essentially graph the cosine function and the sine function. And you also learn that there's a special relationship that the tangent function has with cosine and sine, right? The tangent of an angle is essentially defined as the sine of theta over the cosine of theta, right? It was the same as rise over run. So knowing that relationship that tangent has with sine and cosine, you're actually able to figure out the value for your tangent function at certain angle measurements, right? You're able to figure out what the tan of pi over 2 is using this information. That tangent is the same as sine of pi, sine of the angle over cosine of the angle. And I'll give you an example for what I'm talking about here, right? If I look at pi, right, when theta is pi, if I want to figure out what the tangent of pi is, really what I want to do is look at what my sine of pi is and what my cosine of pi is and put it in that ratio that's mentioned up there. So I'll look at what my sine of pi is. What is my sine of pi? Okay, sine of pi is 0. So I write 0. What's the cosine of pi? The cosine of pi is -1. So I put it in this ratio, 0 over -1. And I know that 0 over -1 really just reduces or simplifies to 0. So that's how I know that my tangent of pi is going to be 0. Again, using this information that the tangent of an angle is defined as sine theta over cosine of theta, I was able to get all of those values in that table. Okay, now we're going to use all of this information to help us graph our tangent function. And you'll notice that this screen right here has 2 bits of information, right? It has a ton of values in our table. We're going to be using that to help us graph. And you'll notice there's a graph here that we're going to be using. Now, I'm going to sort of help guide you towards graphing this function using a series of questions. And what I really encourage you to do is after each question that I ask, I really encourage you to pause the video and see if you can figure out what the answer is on your own before coming back and sort of checking to see if your work is good and then moving on. So here we go. First question. What are the vertical asymptotes for my tangent function? Now, reminder, what is a vertical asymptote? Well, think about all the work that you've done with rational functions, right? Like say you had a function y is equal to 1 over x minus 3. You have to figure out what your vertical asymptotes are. Well, really what you have to do is you have to figure out what values of x made your denominator of the function equal to 0, right? In this case, it's x equals 3. So the same thing applies when trying to figure out your vertical asymptotes for your tangent function. So again, tangent of an angle is defined as sine of theta over cosine of theta. So in order to figure out where my vertical asymptotes are for my tan function, I really have to figure out when is cosine of theta equal to 0, right? My denominator. When is my denominator equal to 0? AKA, when is my cosine of theta equal to 0? So if I look at my table, I'll notice that it's happening at -pi over 2. I notice it also happens at pi over 2, and it also happens at 3 pi over 2. So I actually notice that it's happening at any multiple of 2 pi from one of those angles, right? So I can actually draw vertical asymptotes at any multiple of 2 pi from one of these angles that I have highlighted here. So I'm going to go ahead and draw in our vertical asymptotes. So just remember you're essentially drawing dashed lines through those values. So we've got one at pi over 2, 3 pi over 2, -pi over 2. And I'm going to go ahead and draw another one in here at -3 pi over 2, because again, that's 2 pi away from -pi over 2. All right, so our vertical asymptotes are done. Next question is, what are the zeros of my function? What are the zeros of this tangent function? Okay, now what do I mean, what are the zeros? Well, really, I want to figure out for which values of theta is the tangent of theta equal to 0. For which values of theta is tan theta 0? So again, if I go back to my ratio, sine theta over cosine of theta, really what I'm looking for is when is the sine of theta equal to 0, right? Because the number 0 over any number, it essentially is 0. So if I look at my table, again, I'm asking myself, really, when is the sine of theta equal to 0? And if I look at my table, I notice that this is happening at 0. I notice that it's happening at pi, and I know it's happening at 2 pi, right? And I can see also with my tangent function, the tangent of 0 is 0, the tangent of pi is 0, the tangent of 2 pi is 0. So that's why this makes sense. So really, when is for which values of theta is tan theta 0? It's really happening for every multiples of pi, right? All multiples of pi, I'm going to have these zeros. So if I go back to my graph, I want to actually go ahead and graph these values. And so I'm going to do this at all multiples of pi, right? So again, I know it's at 0 here. I know it's at pi. I know it's at 2 pi. I also know it's at negative pi. And I know it's at negative 2 pi, right? Notice that negative pi and negative 2 pi, they weren't actually on my table, but because I know that I can plot these values or plot these zeros, if you will, at all multiples of pi, I'm able to actually plot those right here. Okay, next question. The next question is, for what values of theta is tan theta 1? Right, so we just looked at where tan theta was equal to 0. Now we want to know where tan of theta is equal to 1. Well, those we're not going to be able to see on this table, but really, in order to figure out where the tan of theta is equal to 1, we're really looking to see when is the sine of theta equal to the cosine of theta, right? Because then it'll be a situation where you have one number essentially divided by itself, it's going to give you 1. So I'm going to go ahead and tell you that one of these angle measurements is going to be pi over 4, because the sine of pi over 4 is 0.707, and the cosine of pi over 4 is also 0.707, right? 0.707 divided by itself is going to give us 1. And even though it's not on this table, I definitely encourage you, again, to pause the video, go back to your unit circle to really check this out and see why this makes a little bit more sense. Okay, so I'm going to go ahead and plot these points, right? These are going to happen at pi over 4, 5 pi over 4, or any value of theta that differs from these by a multiple of 2 pi. So I'm going to go ahead and plot it here. I'm going to plot one over here. I'm going to plot my one here and over here. Okay, 2 more questions for you. First question, where is the function positive? Where is my tangent function positive? So I need to go back to my table and really sort of look at this and figure out where is my tangent function positive. I notice that this is happening between 0 and pi over 2. And it's also happening between pi and 3 pi over 2. Right? So the first quadrant on the unit circle, the third quadrant on the unit circle. And these are going to keep happening. Again, go back to your unit circle and you'll notice more and more where these values are actually positive, where the function is positive, I should say. Now, the reason for why I bring this up is to really kind of help guide us and figure out how to really draw this tangent function. Because now that I know that the values are going to be positive, the function is going to be positive from 0 to pi over 2, I know that when I'm looking at my graph, I can really go ahead and draw an increasing function up until pi over 2, right? I have this 0 right here, and I know that this is going to increase up until pi over 2, right? It's not going to be at pi over 2 because the tangent doesn't exist there, but I can really go ahead and draw this part of my function increasing up until pi over 2. Okay, now I didn't talk about where the tangent of theta was equal to -1. And I definitely encourage you to go back to your unit circle to figure that out. I'm going to go ahead and let you know that these are happening over here at negative pi over 4, and that's going to be happening over at these 2 values as well. Because my next question is, where is this function negative? Right? Knowing where this function is negative is going to help me finish my graph, really. And I can tell automatically looking at my table that this is happening at a bunch of different points, if you will, or different angles. But specifically, because I'm kind of focusing here on between negative pi over 2 and positive pi over 2, I notice that my function is going to be negative between negative pi over 2 and 0. So because my function is going to be negative there, I can go ahead and draw the rest of my graph. Right? Notice that it's decreasing here. It's decreasing and it's staying negative and it's decreasing, right? It started at 0 and it decreased really until negative pi over 2. Why did it not hit anywhere at pi over 2? Well, again, there's a vertical asymptote. The tangent doesn't exist. Okay, last question. Is the graph of tangent of theta, is the graph of tan theta periodic? Well, yeah, absolutely, right? Because whenever theta is increasing by a multiple of 2 pi, both the sine and cosine really took the same values. And so the tangent does have to do that as well. So because I know that fact, I know that I essentially can continue drawing this same pattern, right? It's literally a pattern. I know my graphs aren't the most beautiful, but we can see that the pattern is going to continue. It's going to keep increasing on one end and decreasing on the other end up until those points where the tangent doesn't exist. And so you'll see, actually, I'm going to go ahead and share what this graph looks like on Desmos, but this is pretty much the tangent of theta, right? Again, notice I have zeros at 0, pi, 2 pi, this continues, this keeps going, 3 pi, negative pi, right? All of these are my zeros, and you'll notice that these vertical asymptotes, you can't see the vertical asymptotes, of course, on Desmos, but you'll notice that these functions, they're getting closer and closer and closer and closer and closer to pi over 2. They're never hitting pi over 2 because the tangent doesn't exist there, aka there's a vertical asymptote. So that is how you graph your tangent function.